Hey guys, so today we're going to be dealing with simultaneous equations and we're going to be using the elimination method in order to do this. Before we begin, let me just clarify that there are many methods that you can use to solve simultaneous equations. You have the graphing method, the algebraic method, the substitution method, but today we're only going to be dealing with the elimination method. Now before we go into this, there's some prior knowledge or prior skills and concepts that you need to know before we can go through this, which is how to solve linear equations, algebraic techniques, and substitution. Let's begin with the first example, where we are given two equations here and we have to solve them simultaneously. Now our main goal is to either get the x's the same or the y's the same. Now if I was to get the x's the same, I have a 2x here and a 1x. What would I do to the top to make it a 2x? I would multiply it by 2. But if I want to make the y's the same, I have a 3y and a y. What would I do to the top to make it the same? I would times it by 3. Today, we're just going to make the x's the same. So let's start with the x. In order to make the top the same, I have to multiply the whole line by 2. You can think of it as similar to equivalent equations or something of that consort, where the whole thing has to be balanced. So if I times one thing by 2, I have to times everything in that line by 2. So this becomes then 2x plus 2y equals 14. Only the top changes. The bottom one stays the same. So the bottom one is going to remain as 2x plus 3y equals 17. Now I have to look here, okay, now I can eliminate, and thus why it's called the elimination method, by looking at the 2x and the 2x. Now, what would I do to eliminate the 2x? Would I add them together or would I subtract them? So let's look at the first case scenario where if I added 2x plus 2x is 4x. Does that cancel out? No. So if I did 2x minus 2x, that becomes 0. So I know that now I have to subtract the 2. And you can think of it as like putting a little minus in between each of these. So when I subtract 2x minus 2x, they cancel out. When I do 2y minus plus 3y, so let's write this out as simple. 2y minus plus 3y. This then equals 2y minus 3y. Why does it equal 2y minus 3y? Because you have that plus and minus in the middle. That cancels out to become a minus. So 2y minus 3y is minus y. And the next one is 14 minus 17. And 14 minus 17 is minus 3. So we have minus y equals minus 3. Now we know in order to get y by itself, I have a negative 1 here. So I'm going to write negative 1. That's the same as minus 1 times y. So the opposite of minus 1 times y is to divide both sides by negative 1. And here we see y equals 3. So I found the value of y. Now how am I going to find the value of x? Now I can substitute this y value either into there, the top one, where the y is in the second one, or even in my 2 that I've changed. Now the easiest one to sub it into is the first one because I'm not multiplying by anything there. X plus y equals 7. So I write x plus y equals 7. Now I know y is 3, so I'm going to put that where that y is there. So I'm going to get x plus 3 equals 7. Now here's simple equations. In order to get x by itself, I have to do minus 3 on both sides. And we get the value of x to be 4. X equals 4. So now I found the value of y, I found the value of x. And you use the same steps for any simultaneous equation where we can use the elimination method. Let's go on to example 2. Example 2 is 2x minus 4y equals minus 2 and 3x plus 5y equals 45. Now I cannot multiply the top by anything to make it the same as the bottom, or a whole number, sorry. So the easiest thing to do here is to find either for the x values or the y values what is the lowest common multiple for both of them? So if I look at the number 2 and the number 3, what can I times 2 by and 3 by to get them the same? So if we look at both of them in contrast, making them into 6 would be the easiest option. I times the top by 3 and I times the bottom by 2. What you can also do is you can just look at these and times the top by whatever is on the bottom and the bottom by whatever is on the top. So if we times the top by 3, we get 6x minus 12y equals negative 6. And the bottom becomes 6x plus 10y equals 90. Now, if we look at the 6x and 6x, like we did before, are we going to add or subtract these? 6x minus 6x will give me 0. So I am going to subtract both of them. Now let's look at when we subtract, we're putting a minus in between here. So we have minus, minus, and a minus. So 6x minus 6x cancels out to give me 0. Minus 12y minus plus 10y becomes minus 12y minus 10y. Because remember that plus and minus in between becomes a minus. So minus 12y minus 10y becomes negative 22y, and minus 6 minus 90 becomes minus 96. Now, using equations, how are we going to get y by itself? We're going to divide both sides by negative 22. That cancels that out. We get y equals minus 96 divided by minus 22. Minus 96 divided by minus 22 equals 4.3636. We can round this off to 4.362 dp. Now note, you may get a different answer if you leave it as a fraction or if you round off when you're substituting the next one in. Now that we know y, are we going to sub it into the first one or are we going to sub it into the second one? It doesn't really matter. I'm going to sub it back in to the second one because I don't have a negative there. So then I'm left with 3x. Let's use a different color so we can see the difference. 3x plus 5y equals 45. I'm left with 3x plus 5 times 4.36. You see here we substituted the y for whatever the y value is, equals 45. Simplifying this further, 3x plus 5 times 4.36. 5 times 4.36, and we get 21.8 equals 45. Now, using equations, we're going to subtract 21.85 from both sides to get 3x equals 45 minus 21.8, which is 23.2. And then, in order to get x by itself, we have to divide both sides by 3. X equals 23.2 divided by 3, which is 7.71 dp. Now, you'll notice here that I have found my value for y, and I have found my value for x. Hopefully that helps you with using the elimination method for simultaneous equations.